September 19, 1991. The Alps, straddling the border between Austria and Italy. Two German hikers, Helmut and Erika Simon, are trekking over 10,000 feet when they notice something dark protruding from the melting ice. At first, they think it's trash, maybe discarded climbing gear. Then they look closer. It's a body, not a modern mountaineering accident, not a World War casualty frozen in a glacier. This body is something else entirely. The skin is leathery, darkened by time and ice. The equipment scattered around is ancient, primitive. Nothing like anything they've ever seen. They've stumbled onto Ötzi the Iceman, a man who died in these mountains 53 centuries ago, offering a Copper Age snapshot about 5,300 years old. But Ötzi isn't just old. He's a time capsule so perfectly preserved that he would become one of the most intensely studied humans who ever lived. And what scientists would discover about his body would challenge everything we thought we knew about what it means to be human. When researchers first examined Ötzi's remarkably preserved skin, they found something unexpected. Tattoos, 61 of them, arranged in deliberate lines and crosses on his lower back, legs, and wrists. These weren't decorative, they weren't symbols of status or tribal identity. They were concentrated over joints, over areas that would have experienced wear and stress. The interpretation that emerged is striking. These appear to be therapeutic marks, a form of primitive acupuncture for joint pain. Someone, perhaps Ötzi himself, or a healer in his community, had used sharp implements to make small incisions or punctures in specific locations, possibly rubbing charcoal or ash into the wounds to create permanent marks. The placement corresponds remarkably well to acupuncture points used in traditional medicine for treating arthritis and chronic pain. Ötzi was hurting, his joints ached, and 5,300 years ago, someone tried to help him. But the tattoos were just the beginning. His body held secrets that would reach far deeper than anyone imagined. His clothing revealed extraordinary craftsmanship and intimate knowledge of high-altitude survival. These weren't crude animal skins thrown over his shoulders. This was expert cold-weather gear, carefully constructed for function. Leather leggings, stitched and fitted, a loincloth, a coat made from goatskin, pieced together from multiple hides with sinew thread. The coat alone represented dozens of hours of skilled labour. On his head, a bearskin cap, the fur providing insulation against bitter alpine winds. And his shoes, perhaps the most ingenious piece of all, featured grass insulation packed between layers of leather. Grass acts as dead airspace, trapping warmth. It's the same principle modern winter boots use with synthetic insulation. Ötzi's people understood thermodynamics long before the physics were formalized. He was dressed for the environment, prepared for cold, ready for high altitude. And yet, something went wrong. Scientists wanted to know what this man ate, what his daily life looked like, what resources his people exploited. So they examined his stomach contents, the partially digested remains of his final meal. What they found painted a picture of dietary diversity. Ibex, a wild mountain goat adapted to steep rocky terrain. Red deer, a forest and meadow species. And einkorn wheat, an ancient grain that requires cultivation, planting, tending, harvesting. This wasn't a pure hunter. This wasn't a pure farmer. This was someone whose economy blended both strategies. A mixed hunter-farmer diet reflecting a way of life that straddled two worlds. He hunted wild game in the high country, but also relied on agricultural products from lower elevations. It suggested seasonal movement, transhumance, herding and farming at certain times of year, hunting and foraging at others. But his stomach contents weren't the only part of his interior that held revelations. His cells, his DNA, were about to tell a story about deep ancestry and the reshaping of Europe itself. When scientists finally sequenced Ötzi's genome, expecting perhaps to confirm his place in the Bronze Age European landscape, they found something more complex. He was lactose intolerant, unable to digest milk sugar into adulthood. That's the ancestral human condition. The genetic mutation that allows lactose tolerance in adults evolved relatively recently and spread through European populations after the advent of dairy farming. Ötzi lived at the cusp of that transition, but hadn't inherited the mutation. He also carried genetic markers suggesting a predisposition to cardiovascular disease, atherosclerosis, hardening of the arteries. Whether this was manifesting in his lifetime is unclear, but the genetic risk was there, written in his DNA. But the real revelation came from his ancestry. Ötzi's genome showed clear links to Anatolian early farmers, the people who spread into Europe after 7000 BC, bringing agriculture, domesticated animals, pottery, and settled village life. They moved up from the Near East, through the Balkans, and gradually replaced or absorbed the hunter-gatherer populations that had lived in Europe since the Ice Age. Ötzi was part of that wave. His ancestors had made that journey. And by 3300 BC, when he died, their descendants had thoroughly reshaped the European genetic landscape. He wasn't descended from the deep Ice Age Europeans who had survived glacial maxima. He was part of the new order, the farming populations whose way of life would eventually dominate the continent. His gear told its own story about his expertise and intentions. This was no casual wanderer. Ötzi carried the equipment of an experienced outdoorsman, someone who spent significant time in the high country and knew what he needed to survive. A copper axe, a remarkable piece of technology for the time. Copper was still relatively new, still prestigious. Metalworking required specialized knowledge, trade networks, access to ore sources. The axe wasn't just a tool, it was a status symbol. A quiver held 14 arrows, though only 2 were finished, fully fletched and ready to shoot. The others were rough shafts, works in progress. Had he been making them as he travelled? Was he interrupted before he could complete them? A flint knife with an ashwood handle, the blade sharp and functional. An unfinished yew longbow, over 6 feet tall, carved but not yet ready to string and use. Yew is ideal for bows, flexible yet strong, able to store and release energy efficiently. But this bow was a work in progress, like the arrows. And 2 birch bark containers, lightweight and waterproof, perfect for carrying provisions or collecting materials. This was a toolkit. The gear of someone who knew the mountains, who expected to be out for some time, who was prepared. But preparation doesn't always mean survival. The forensic analysis of Ötzi's body revealed trauma. An arrowhead was lodged in his left shoulder, buried deep in the tissue. Initial interpretations focused on that wound. The subclavian artery runs beneath the collarbone, carrying blood from the heart to the arm. If the arrow damaged that artery, Ötzi would have bled out rapidly. Minutes, maybe. Fatal subclavian artery damage seemed like the obvious cause of death. It fit a narrative. Ötzi was murdered. Shot from behind, perhaps ambushed. He staggered, collapsed, and died on that mountain pass. The cold preserved him before scavengers could scatter his remains. A violent end to a Copper Age life. But as researchers continued to study the body, that story started to unravel. The arrow wound, while serious, might not have been immediately fatal. The damage patterns didn't quite match a catastrophic arterial bleed. And there were other signs. Bruising. A revised interpretation emerged. The arrow struck him, yes. It incapacitated him, certainly. But the killing blow might have been the environment itself. Injured, unable to move effectively, Ötzi succumbed to hypothermia. He froze to death on that high alpine pass, wounded and alone. But even that conclusion, dramatic and well supported, wasn't the end of Ötzi's story. Because in 2025, researchers looked at his body in a completely new way and discovered something no one expected. A team published a study in communications biology using advanced 3D modeling and geometric morphometrics to digitally reconstruct Ötzi's thorax, his ribcage. This wasn't just taking measurements. This was correcting for 5,300 years of glacier-induced distortion, of ice pressure slowly deforming the body, of ribs being compressed and shifted out of their original position. When they reconstructed what Ötzi's chest actually looked like during his life, the result was startling. He had a larger, more barrel-chested ribcage than expected, wider at the lower chest, narrower at the upper chest, still retaining the overall globular shape characteristic of Homo sapiens, but with proportions that didn't quite fit the standard model. The researchers described it as ambiguous. Not quite the slender cylindrical thorax often associated with modern humans, not the flat, wide, stocky thorax of Neanderthals, something in between, something adapted, and that's where the story gets really interesting. Because Ötzi's unusual chest shape tells us something profound about how humans adapt to extreme environments. His ribcage was framed as an adaptation to a life of seasonal alpine transhumance around 3300 BC. Think about what that means. Ötzi spent significant time at high altitude, where the air is thin, where every breath delivers less oxygen. A larger, barrel-shaped chest allows for deeper breathing, for greater lung expansion, for more efficient oxygen extraction from thin air. It also provides improved heat retention. A more voluminous thorax means more internal space, more capacity to maintain core body temperature in severe cold. This fits with Bergman's rule. an ecological principle stating that organisms in colder climates tend to be larger or more robust, maximizing volume relative to surface area to conserve heat. But here's the crucial detail. Ötzi's chest avoided becoming too flat and wide, the shape characteristic of Neanderthals. Why does that matter? Because Neanderthals lived in Ice Age Europe, in environments that were consistently cold. Their body plan was optimized for continuous cold stress. But Ötzi wasn't living in a constant ice age. He moved seasonally. High altitude in summer, lower valleys in winter. His body needed to handle cold efficiently without overheating in milder conditions. A Neanderthal-like thorax would be a liability in a temperate valley. Too much heat retention. Too much insulation. Ötzi's ambiguous chest was a compromise, a body plan flexible enough to handle environmental variation. But to understand just how significant this finding is, you need to think about Ötzi in context. Because human rib cages are far more variable than we ever realized, the researchers compared Ötzi to a spectrum of ancient and modern human thoraces, and what emerged was a picture of stunning diversity. Nazlet Keita, a skeleton from Egypt dating to around 33,000 years ago, had a small cylindrical ribcage, ideal for heat dissipation in a hot climate. Less volume means less heat generated metabolically. More surface area relative to volume means better cooling. Ohalo, from Israel, around 23,000 years ago, showed a slender cylindrical thorax suited to temperate foraging in Mediterranean environments. Not optimized for extreme cold, not optimized for extreme heat. A generalist body plan. Then there's Dolny Vostonis, from the Czech Republic, around 31,000 years ago. This individual had a massive, near Neanderthal-sized chest, built for glacial cold. Ice Age Europe demanded robust bodies capable of generating and retaining heat in brutal conditions. And, for comparison, actual Neanderthals. Kebara II from Israel and Shanidar III from Iraq, both with stocky, flat thoraces, the classic Neanderthal body plan. Wide, barrel-shaped from the front, but flattened from front to back. Maximum volume with minimal surface area. Perfect for Ice Age cold. Even older, the Nario-Katome boy, a Homo erectus juvenile from Kenya, dating to about 1.5 million years ago, showed a robust thorax, different in shape from modern humans but built for endurance, for long-distance travel in the African heat. The synthesis from all these comparative samples is revolutionary. The idea that modern humans have a uniformly slender ribcage, a single body plan that defines our species, is wrong. We don't. We've always been variable. Our bodies reflect climate, lifestyle, work demands, diet, and ancestry. Ötzi's preserved body, frozen at the moment of death, gives us a chance to see that variation in stunning detail. He wasn't an outlier. He was an example of how flexible human morphology really is. For decades, anthropology taught that modern humans evolved a gracile body plan, slender and lightly built compared to our archaic relatives. We lost the heavy brow ridges, the thick bones, the robust musculature. We became the thinking apes, using tools and culture to compensate for physical weakness. But that narrative was always too simple. It ignored the reality that humans colonized nearly every environment on Earth and that bodies adapted accordingly. Arctic peoples developed different proportions than equatorial peoples. High-altitude populations evolved different chest shapes than lowland populations. Ötzi is direct evidence of that process in action. 5,300 years ago, long after the last ice age, long after Neanderthals disappeared, human bodies were still diversifying, still adapting, still responding to local environmental pressures. His barrel chest wasn't a Neanderthal throwback. It wasn't a primitive feature. It was a solution. An adaptation. A body plan optimized for a specific lifestyle in a specific environment. And that challenges the entire framework we've used to think about human evolution. We tend to think of evolution as something that happened in the deep past, during the transition from archaic to modern humans. But Ötzi proves that evolution was still shaping bodies in the Copper Age. It was still active in historical times. It's probably still happening now, though too slowly for us to perceive within a single lifetime. The tattoos, the clothing, the diet, the genome, the gear, the forensic evidence of his death, and now the shape of his chest, every detail of his preserved body tells a story, not just about one man, but about the incredible adaptability of our species. He lived in a transitional time. Agriculture was spreading, but hunting remained important. Copper tools were emerging, but stone tools still dominated. His people were genetically replacing earlier populations, but also absorbing their knowledge, their techniques, their understanding of the land. and his body reflected all of that complexity. He wasn't a standardized modern human. He was a person shaped by his environment, by his ancestors, by the demands of survival in a challenging landscape. The 2025 thorax reconstruction is the latest chapter in Ötzi's ongoing scientific legacy, but it won't be the last. New technologies will enable new questions. We'll extract more information from his tissues, his bones, his DNA. We'll refine our understanding of his life, his health, his final hours, but the core revelation stands. Human bodies are not fixed templates. We're not stamped from a single mold. We're variable, adaptable, responsive to our environments in ways both obvious and subtle. Ötzi's barrel chest is a window into that variability. It's proof that even within our species, even within historical times, bodies differ in significant ways. And those differences aren't random. They're meaningful.